Hello everyone and welcome to Augmetic. So I am here to introduce our one of the product that is WinIO 16UI8UOM. It's an 16 channel universal input and 8 channel universal output which is communicating through the RS485, that is a Modbus. So here we have the module. So in this module here we have the power supply part. For this power supply we have provided the provision that is a positive and the negative, where we can connect up to 24 volt DC or AC in any direction. So here we have the bridge rectifier which protects the board during the reverse connection. So in this board here we have the RS485 part. For this RS485 we have provided the provision that is a for the positive, B for the negative, where we can connect with the RS485 cable to the PC to control the UIO board. So here we have the jumper part. So where we can select the slave ID and the baud rate through the RS485. During the new slave ID and the baud rate, so jumper should be in an open loop, and to get back to the board as a default, the jumper should be in a closed loop. So here we have the reset button. So whenever we are changing the slave ID and the baud rate, just we need to press the reset button once, so the board will get configured with the new addresses. So here we have the universal input part. So here we have the total 12 universal input, and here we have the another 4 universal input, total 16 universal input. In the universal input, where we can select as a multiple channel as a analog input, on multiple channel as a digital input. So here we have the universal output part. So total we have the 8 channel as a universal output, where we can select multiple channel as a analog output or a digital output. So in the next step we will get to know how to configure the UIO board. So here we get to know how to configure the 16UI8UO module with the RS485. So where we are using the Modbus pole for the reference. So here I have connected the Modbus board. So in the base board I have connected with the RS485 cable to the PC to configure the board. So here I have provided the 24 volt DC. So now open the MB pole and go to the connection. So click on connect, and the serial port should be a connection, and in the USB setting, so select the port which you are using for the serial communication, and the by default address, that is a 9600. It will be a baud rate and 8-bit data bit, and parity will be a none and stop bit will be a 1. So click on OK. So the board has connected properly. After connection, here the RX-TX will be pulled continuously. So the here board has communicating with the RS485 properly. So from the at the first register, we can select the up to 4 channels, that will be a UI1 to UI4. The starting 4 register is used for the UI channel, and the next 2 register is used for the EO channels. So starting 4 register, for the each register you can select 4 channels at a time. So in the first register I have provided the 4, that will be a AI 5 volt. So 1 is for the DI, 2 is for the AI 10 volt, and 3 is for the NTC sensor, and 4 is for the AI 5 volt. So at the starting 8 channels I have selected the AI 5 volt. So now I will change the channel 5 to 8 as a NTC sensor. So I will provide the value as a 3. So the channel 1 from the channel 4 will be a AI 5 volt, and the channel 5 to the channel 8 will be a NTC sensor input, and the channel 9 to 12 it will be a DI, and 13 to 16 it will be a DI. So from the 9th channel to 16th channel it should be a DI only. So in the EO channel So for the first 4 channels I have provided the 1, that will be a DO, and the another 4 channels I have provided as a 0, that will be a AO. So at this 7th register, here we can read and also write the baud rate. So currently we have the 960, it indicates the 9600, which internally multiply by the 10. So here for the SID, that is a slave ID, which is 1 by default. So we can configure and we can change the slave ID and the baud rate in the same register also. So now I have provided the setup mode. So for the UI, we need to change the registers. The starting register will be a address 10, that is here showing the 40011. Okay, and the quantity will be 16. So here I am getting the UI channels. So from here UI1 to UI16. So at the first 4 register I have provided the AI 5 volt, and the next 4 register I have provided the NTC. So and the next 8 register I have provided as a DI. The starting 4 register I have selected as a AI 5 volt. So I will take a 5 volt reference to check the first 4 channels. So here I have taken the male to male jumper. So I am taking the 5 volt reference. So this is my AI1. It is a 12 volt reference. Here I have the AI1. So whenever I shot with the AI1, I am getting the 996 as a resolution. It is for the 10 bit. So where I am using for the 5 volt reference. So for the AI2, I am getting the same. So same as the AI3 and AI4. So for the next 4 channels, I have connected with the NTC sensor. So I have set the channel as a NTC. So here I have the NTC sensor. For this NTC sensor, so in the UI channels, for connecting the every sensors, the ground should be a common. So here we need to take the ground as a reference for the common. So at the 5th register, so at the 5th register I am getting the 26.2 as a temperature. So at the 6th also I am getting the 26.1, same as the 7th and 8th. So this is the about NTC sensor. I have selected the particular channels. So here from the next channels I have selected as a DI. So I need to take a 12 volt reference for the DI. So here I have the 12 volt reference. So by taking this 12 volt reference from the channel 9 to 16 as a DI. So here I have the next 4 channels. So this is the 9th channel. So whenever I shot with the 12 volt reference, here the LED has turned on, and also at the Modbus I am getting the data as a 1. So at the channel 10th, 11, 12, and these two are the common grounds. So here the another 4 channels. So here also LED turn on, and also at the Modbus I am getting the value as a high. So this is all about the UI channels. So now we will get to know for the UO channels, that is a universal output. So for the UO, from the first 4 register I have selected as a DO, and the next 4 registers I have selected as a AO. So for the UO channels, so address is a 26 and the register that will show as a 40027, and the quantity will be a 8. So here it will show the from here to 4, that will be a UO 4, and from here to here is the another UO 4. So starting 4 register I have selected as a UO as a DO. So here I will provide the value as a high 1. Here the DO 1 has operated. So at the second register I will provide the value as a 1 high. At the second also the LED turn on. So at the fourth register also I will provide the high value. So fourth LED is turn on. For the AO I have selected the next 4 channel. So I will provide the resolution. As per the resolution I will get the voltage at the analog output. So here I will provide the random resolutions. It will be a 10 bit 0 to 1023 resolution will be provided. So to check this AO we need one multimeter. So here I have the multimeter. So here I have the 4 channels. So for this here we have the ground reference. So we need to take the ground reference. So with the ground reference, so here I have the channel 1 analog output. So at the channel 1 I have provided the 1023, that is a full resolution. So I am getting the voltage as a 9.9, that will be a 10 volt. So at the channel second I have provided the 512 as a resolution. So the voltage it will be a 5 volt. So at the third channel I have provided the 700 resolution, it will be a 6.8. So fourth channel I have not provided anything, so it will show as a 0 volt. So you can configure UI and UO at the any time as per the requirement, but for the UI channels from channel 9 to 16 it will be a DI as default. So go to the registers and change the address. So here you can configure anytime for the UI and UO. So here we will get to know how to configure this soft setting, that is a baud rate and the slave ID. So at the register 7 it will be a baud rate. At the single register we can read the baud rate and also we can write the new baud rate. So for the same as the slave ID also. So here the current baud rate is a 960, by default it is a 9600. So internally it will be a multiply by the 10. So here I will provide the 115200 as a baud rate. So now I will provide as a 11520. And now I will provide as a slave ID, that is a 15. So whenever we are changing the slave ID and the baud rate, here the jumper should be in a single mode or it should be in a open. So now press the reset once, the board will get configured with the new slave ID and the baud rate. So here I will get the timeout error. So after getting the timeout error, disconnect the board and connect the board with the new configuration. The baud rate will be a 115200 and the slave ID is 15. So here the board has connected with properly for the new settings. So this is for the changing the slave ID and the baud rate. So now we get this back to the default addresses. For that we need to put the jumper in the close mode. After closing the jumper, just press the reset once. So here you will get the timeout error. So disconnect the board and connect the board with the default addresses. The board has connected properly for the default addresses.